Welcome back. We're still in section 4.1. We're going to be talking about degrees and radians. So when we're talking about a degree, the measure of 1 degree is equivalent to 1/360th of a complete revolution. So we're going a total of 360 degrees for one circle. So a full revolution is 360 degrees. So since 2 pi is one revolution, 2 pi is equal to 360 degrees, pi is 180 degrees, and you want to keep in mind, every 30 degrees is pi over 6, and every 45 degrees is pi over 4. We're going to be seeing that quite a bit. So to convert from degrees to radians, you want to multiply by pi radians over 180. And then to convert from radians to degrees, it's 180 over pi. You can see they're very similar except where pi is and where 180 degrees is. So the way I like to keep this in mind, what we want to do is we want to get the degrees to cancel out. So we convert from degrees to radians. So we're going to multiply by pi over 180. You can see degrees on the top and degrees on the bottom cancel. That's our goal. So now what we have is 135 and 180. They're both divisible by 45. 135 divided by 45 is 3. 180 divided by 45 is 4. So we're going to get 3 pi over 4 radians. For 320 degrees, we're going to multiply by pi over 180. They're both divisible by 20. So you get 16 and 9. So we end up with 16 pi over 9 radians. 540, you're multiplying by pi over 180. They're both divisible by 180. So that's going to be 1. And 540 divided by 180 is actually 3. So it's going to give us 3 pi radians. 60 degrees, multiplied once again by pi over 180. So they're both divisible by 60. 60 divided by 60 is 1. 180 divided by 60 is 3. So we end up with pi over 3 radians. Negative 270. So we're still multiplying by pi over 180. They're both divisible by 90. 180 divided by 90 is 2. Negative 270 divided by 90 is negative 3. So we're going to get negative 3 pi over 2 radians. Then negative 30, so we're still multiplying by pi over 180. They're both divisible by 30, so that becomes a 6 in the denominator, and that's a negative 1. So we get negative pi over 6 radians. So that's converting from degrees to radians. To go from radians to degrees, we want the pi's to cancel out. So we know we're going to multiply by 180 over pi so that the pi on the top and the pi on the bottom cancel. So what we end up with is, I'm just going to simplify it in the next step just because it's a little messy. Negative 180 over 2, which is negative 90 degrees. So then we're going to multiply by 180 over pi. The pi's cancel. 180 over 6. And that's going to be 30 degrees. 9 pi over 2. So we multiply by 180 over pi. The pi's cancel. I'm actually going to cancel a little bit more. The 2 and then 180, that becomes a 90. That becomes a 1, so we're going to get 810 degrees. 5 pi over 6 radians, so we're going to multiply by 180 over pi. The pi's cancel. The 6 becomes a 1, the 180 becomes a 30. So we're going to end up with 150 degrees. 2 radians, so we're going to multiply by 180 over pi. So that's going to give us 360 divided by pi. And when we do that, we're going to get about 114.59 degrees. Remember, pi is a value about 3.14. And 3 radians, we're going to multiply by 180 over pi. So we're going to get 540 divided by pi, which is about 171.89 degrees. So that's converting from degrees to radians. Keep in mind, a full circle is 2 pi radians, or 360 degrees. Finding the length of an arc. For a circle, the radius, central angle of theta, intercepts an arc of length s. So to find the length of an intercepted arc, s equals the radius times theta, the radius times the central angle. Theta is measured in radians. Keep that in mind. When we're looking at theta, theta must be converted to radians. So for number 30, a circle has a radius of 4 inches. Find the length of the intercepted arc. So the length of the intercepted arc, s, equals r times theta. So it's the radius, which is 4 times. Now theta is not 240 degrees. We have to convert that to radians. So we're going to multiply by pi over 180. They're both divisible by 60. So you're going to get 3, and you're going to get a 4. So you're going to get 4 pi over 3. So that's your theta. Not 240 degrees, but 4 pi over 3 radians. So when you multiply, you're going to get 16 pi over 3 inches, which is about 16.76 inches. That's the length of the arc. The key there is to change your degrees to radians. So for number 31, find the length of the arc. So s equals r times theta. Now keep in mind theta, 150 degrees. Multiply that by pi over 180. They're both divisible by 30. So you're going to get 6 and 5. So theta is actually 5 pi over 6 radians. So s equals 5 times 5 pi over 6. So the intercepted arc is 25 pi over 6, which is equal to about 13.09 meters. So there's the exact and the estimated length. 32, once again, s equals r times theta. Theta, 45 degrees, we have to change that to radians, so you multiply by pi over 180. They're both divisible by 45, so that's a 1, and that's a 4, so it's going to be actually pi over 4 radians. So it's going to be 10 times pi over 4. So it's going to be, when you reduce, 5 pi over 2 inches, which is about 7.85 inches. So there's the exact 5 pi over 2 and the estimated 7.85. Number 33, same thing. S equals r times theta. Now theta, 2 radians. It's in radians already, so we don't have to do anything. So s equals 5 times 2. So s is going to be 10 miles. It was already in radians, we didn't have to do anything. S equals r times theta. 15 times. Now, pi over 4 is already in radians. So 15 pi over 4 is the exact, and that's about 11.78 inches. So there's the exact and the estimated arc length. The key there is to make sure that theta is in radians. Okay, that is it for this part. I will see you in the next lesson to talk about linear and angular speed, and also talking about a few other things with conversions. Thank you.